In this video, we're going to delve a little bit deeper into logic and logical arguments. A logical argument they have two parts. The first part you could look at as premises, or we could just call it single premise. This would be things that we know, things we know to be true. Any assumptions are up here. Assumptions are things that we're assuming to be true. Rules, whatever. There's a whole collection of things that could be here that indicate why something should be true. So we use any of those for our premises. And the second part is pretty simple, a conclusion. We use the information from part one to deduce a conclusion. This is using something referred to as deductive reasoning. This is not the same as inductive reasoning where we looked at patterns. Deductive reasoning is something different, as you'll see as we go through the problems. Let me start it with a definition. A logical argument is valid if all of the premises being true force the conclusion to also be true. Now, it's important to understand this. Whether a conclusion is in fact true in real life isn't the importance of these arguments. It's whether the conclusion follows from the assumptions made. Let's do an example and determine if the following logic is valid. So let's move on to an example. The way they look is a bit different, but we're going to write this way. Is the following argument valid? The way it's structured is this. We put no accidents, happen on purpose. And then we have spilling the beans was an accident. So those are our two premises that we're going to use. Then we follow that with a line here. And the second part is the conclusion. The beans were spilled on purpose. So what we have here, right here, these things here are premises. These are things that we take to be true. That's the first part. The second part is the conclusion. So is it true that if we make the assumptions that 1 and 2 are both, or that both premises are true, does that force the truth of the conclusion? If the conclusion is the thing that is forced, then we are forced to say that the argument is valid. If that's not the case, like if there's some way that that conclusion was not derived from those premises, then it's an invalid argument. So let's go ahead and take a look and see what we have here. I'm going to grab my cursor so I can follow along with this. The beans were spilled on were spilled on purpose. Was it purposefully done? Let's take a look. No accidents happen on purpose. I'm assuming that spilling the beans is considered an accident. Spilling the beans was an accident. Well, obviously I just said that. Okay. So the beans were spilled on purpose. No accidents happen on purpose. Spilling the beans was an accident. Is it possible that this could follow the beans were spilled on purpose? So here, I guess we have spilled beans. They're on the floor. Was it on purpose? Was it on accident? Well, these two things tell us that spilling the beans, if it is an accident, then that accident did not happen on purpose. So if beans were in fact spilled, then it was an accident. So this conclusion cannot be drawn from those two premises. So this is an invalid argument. Let me see if I can write it up here. Let's take a look. There are spilled beans. What do the two things tell us that should have been the result? If there are spilled beans, we know what? That it was an accident, so we know it was an accident. And we also know that accidents don't happen on purpose. So we have that it was an accident. Accidents don't happen on purpose. So since it was an accident, then it was not on purpose. This implies that it was not on purpose. But the conclusion that we wrote under there is diametrically opposed to that. That conclusion should really say the beans were spilled on accident, and then it would have been a valid argument. So this would have worked if we would have done no accidents occur on purpose. Spilling the beans was an accident. Therefore, the conclusion, I many times write this little symbol, although the book doesn't. Those three little dots are some sort of mathematical symbol for indicating therefore, or it might not have even been math, it may be logic that has used those. Therefore, the beans were spilled on accident. This now is valid. So many of these examples, I'm going to, if I have an invalid argument, I'm going to try to do something to the argument to make it valid. Is the following argument valid? And it goes like this. All rainy days are cloudy. Today is not cloudy. Therefore, today is not rainy. So the way maybe to think about this is, let's pick today. Today it's not cloudy. That's true. All rainy days are cloudy. So today can't possibly be rainy, because if it were rainy, it would have to be cloudy, according to the first statement. So we are forced into today is not rainy. So this is a valid argument. So I don't have to do anything to fix it up. Once again, if you think about today, today is your subject. Does it follow by the two things, the two premises? And I think it does easily. If you think, let's start with, if today were rainy. If today were rainy, then according to the first part of the arguments right up here, if today were rainy, then it would have to be cloudy. But that is in direct contradiction to this second line. So what are we forced? Today is not rainy, is the only conclusion we can make. Is the following argument valid? This one says all blogs contain writing. This book contains writing. Therefore, this book is a blog. So once again, let's focus our attention on the book itself. This book is a blog. All right, if this book is a blog, then according to part 1, all blogs contain writing. So that's not in contradiction to that. And this book contains writing. I don't know that that necessarily follows. It says all blogs contain writing, and it just happens to be the fact that this book also contains writing. But the first line, look at the first line. The first line does not say all books are blogs. It doesn't say that. It doesn't say all books contain writing, although that's probably true. We can't make any assumptions outside of these two items here. So I'm not talking about all books here. I'm talking about all blogs. The fact that this book happens to contain writing is incidental. This is not no way is this book forced to be a blog. Now, if I change this first sentence to say all writings are blogs, well, then that's a different statement. Or all collections of writings are blogs. Now, that would be one way to correct it. But since this does not follow, we have an invalid statement or invalid argument. How can we make it truthful? There's more than one way to do this. We're just going to try to, you can usually switch around something. I think in this case, let me keep the first line, all blogs contain writing. And then I'm going to put this book as a blog next. Therefore, this book contains writing. So what we have here, it's a little complicated, but this book contains writing does follow. Let's concentrate on this book. All right, so I have this book in front of me. This book I know to be a blog. And I know that all blogs contain writing. So I can go, this book is a blog, implies this blog, well, and since it's a blog, it contains writing. Therefore, this book contains writing is valid now. Is the following argument valid? Here we have all drivers have a photo ID. As a matter of fact, that is not actually true in real life, but that doesn't matter. Since we write it as one of the premises, we assume it to be true. K has a photo ID. Therefore, K is a driver. Hopefully you're starting to see a little sort of a pattern here. K, all we know about K is that she has a photo ID. The first line of the premises, this first line doesn't talk about everybody with photo IDs. It's talking about all drivers, and that's not necessarily referring to K. There's no indication in these two things that K drives anything. So this is an invalid argument. However, I can make it valid. Let's validize it by switching the last two lines. So I'll go all drivers have a photo ID. K is a driver. Therefore, K has a photo ID. Now you can see where it follows. So let's take a look. K is a driver. So K is a driver. Then according to the first line here, since she is a driver, that's going to imply that she must have a photo ID. So now, of course, it's a valid argument. Now we're going to use Euler diagrams. That is, after all, the name of this video. These are visual representations of these problems that hopefully help you out. So let's do a problem. Is the following argument valid? So I'm going to redo some of these problems actually. No accidents happen on purpose. Spilling the beans was an accident. Therefore, the beans were spilled on purpose. Notice the first line is dealing with something called purpose, and the second one is accident. So we can think of this as two circles. Things done on purpose and accidents. Obviously, they're disjoint. This is part of why the logical reasoning is going to be difficult in this one. It's probably going to be invalid, is because we have that going on. Let's let X, just like you do in math, I'm going to let a variable stand for spilling the beans. Alright, so let's take a look. I am told that X, since it's spilling the beans, I am told that spilling the beans was an accident. That means X has to lie inside of that circle. However, that's disjoint from this circle, so it can't possibly follow from this circle because it's not inside of it. So because of that, since X is not in the set of purposeful purposes, I guess, purpose, since X is not part of the actions on purpose, this does not follow. What I need is for X to be inside of there because I'm accusing this person of doing something on purpose. So from this, we see that the argument is invalid. Our next argument, we have all rainy days are cloudy. Today is not cloudy. Therefore, today is not rainy. So today is sort of interesting. We can let X equal today. And the first line says all rainy days are cloudy. That means we have clouds, and then we have rainy inside of it. Because it says every rainy day is a cloudy day also. Now, let's take a look at today. It says today is not cloudy. So it means that it must not be inside of the cloudy days circle, so X is out there somewhere. Well, that definitely means that X is not in rainy days, which was exactly what this line here was telling us. It says that X is not in the set of rainy days, or therefore X is not rainy, and so this argument is valid. Another one of our arguments, we had all blogs contain writing. This book contains writing. Therefore, this book is a blog. Well, let's go ahead and take a look. All blogs contain writing. So we're going to have is in the circle of writing, the blogs are inside of it. This book contains writing. So let X equal this book. Now, if X were inside of blogs, that would be fine. But nothing in the first two lines tell me that X can't lie there. It could lie outside of blogs, but it has to be inside of the writing circle. We just happen to know that there are some writing things that happen not to be blogs. There's no guarantee then that this X should be forced to be inside the blog circle. So whether the thing is a blog or not is irrelevant. The fact is we cannot make the conclusion that the book is a blog based on the assumptions I am making. So this is invalid. Because it is possible for X to not be inside blogs. But it's still inside of the writings. Let me put this word, let me attach possible. It's possible for X to be in writings, but not in blogs. All drivers have a photo ID. K has a photo ID. Therefore, K is a driver. You're going to find something similar to the last situation. It says all drivers have a photo ID. So the people with photo IDs is the larger circle, and then the drivers are a smaller circle. Now it doesn't say that K is a driver. It says that K has a photo ID. So according to this second statement here, all I know is that K has a photo ID. Nothing is forcing K to be inside of the driver's spot. So X can equal K, and it's possible for X to be in the photo ID set, but X not to be in the set of drivers. So that means this argument is invalid.